Right, so let's take this example a step further and make it interactive for artists to work with. Python can help out there as well, of course. First, I want to only apply the green color to half of the points. This is the code we had, right? We've initialized the color value to green, but I want to initialize it to black because I'm now going to tell half of the points that they will be green rather than all of them. So first I make them all black, and then I make a loop over the points. So we can go for point in geo.points, and we've seen before that that function retrieves the point number for each point. We end the line with a colon, and we start with 4 indentations, 4 spaces on the next line. Then we type if point.number modulo 2 is equal to 0. Yeah, and we do that by using our percentage mark and close off with a colon again. And then we do another 4 spaces indentation on the next line, point.set attrib value to set it, because we've already created an attribute and now we're going to call the attribute and set it through this function. Pay attention to the capital V and capital A. This is called camel case type, and it's important in the syntax. If you use lowercase instead of the uppercase letters, you'll get a syntax error. So now in set attribute values brackets, let's add cd as a string, and this is where we would normally pass in a vector value, but instead let's pass in a variable called color, and we're going to set the color to reflect that vector value. Let's copy the original values here, and we're going to say color is and paste in what we've just copied. Now, of course, they're all black. The code is fine, but we haven't yet specified the variable called color to be green, so we set the middle value for green to be 1. What modulus does is it looks at the point number, which we fetch here, and then it sees how many times 2 fits into that. Then if 0 is left, it will include that point. So for example, point number 4 will have 2 fit into it perfectly twice, and then leaves 0, so that will become green. But if we would take point number 5, 2 would fit into it twice, and then it would leave 1. So the remainder of that would be 1, meaning that point would remain black. This is because the if statement says, if modulo 2 is equal to 0, make the point green. But it's not 0, it's 1, so it returns false. With point number 4, 4 modulo 2 is indeed 0, returning true, and thus making the point green. This is a useful way to isolate a number of points, say half, a third, a fourth, and so on. I use it every now and then to isolate just a given number of points, or to call a point cloud, for example, evenly everywhere. Alright, let's go ahead and add a few parameters for us to play with. Let's go ahead and modify our parameter interface. Up top here at the cogwheel, edit parameter interface. It falls a bit off screen, but it should say edit parameter interface at the top. And then we get a window here. So above the Python code, let's insert a separator. They can be found near the bottom. Click this arrow and it should be inserted. Just move it up top. And then above there, what we want to do is we want to get 3 floats. Let's grab the floats and move them up as well. And we want to call these R, G, and B. So let's get the first one, name R. I always keep the name lowercase or as much as I can, and then the label will be capital. So this one will be G and G, and B and B. So let's make sure that it's correct. I can already see that the label on G is incorrect, and on B as well. Sometimes if you don't hit enter, it doesn't actually pick up the changes. Let's also make sure that the range on each is 0 to 1. You can click range on here, and by default it's 0 to 10. But let's change that to 0 to 1. On the G as well, range on 0 to 1, and B as well. Hit apply and accept. Now if we slide these, we should be able to slide them anywhere between 0 and 1. That's correct. So now we can use Python like you can use Vex to reference these channels. Let's go in here and insert R, G, and B as custom variables. Now I'm going to say R is who.node, and to reference the current node itself, we can place a dot in the middle, and then I want to reference the parm R. So we've just named them, and even though the label is a capital letter, we know the name is set with a lowercase letter, which is thus what we will reference. Now we can say .eval, which is a function that evaluates to whatever value the parameter you're calling is set to. I'm going to have to assign this to every one of them, and for this one I will get the G channel, and for this one I'll get the B channel. So now if we select these values, the R, G, and B variables in the code will evaluate to different values between 0 and 1, as we've specified the range of each parameter to be, depending on the position of the slider. What we can do now is go into our color variable, and instead of assigning direct float values, we can say color is R, G, and B. And now we should be able to play with the sliders and see those values reflected in the colors of the point cloud. So now we've got all of them blue, bright blue, and we can play with the red some more. This is a useful way of using Python if you want to get interactive parameters to work on your point cloud, modeling whatever it is that you're doing. And what it does is basically use this node to instantly change these values of what you're doing, and you can then continue underneath there. This wraps up the Python Wrangle example, if you want to call it that, and the next example will be a custom built Python node from a null. Let's go ahead and do that.